Hello, in this discussion we're going to be talking about sum and difference formulas in analytic trigonometry. Now these are formulas you need to write down. You need to have them somewhat memorized. A lot of the proctored exams, these formulas I will provide you, okay? And I'll go in a little bit more detail as the test gets closer of what formulas you will need to know and what you will not what you won't need to know. So what you will and what you won't need to know, I'll let you know as the time comes. All right. So here is the sum and difference formulas for cosines. The cosine of alpha plus beta is the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And the cosine of alpha minus beta is going to be the cosine of alpha, cosine of beta, plus the sine of alpha and the sine of beta. So this is the sum and difference formulas for cosines. And yes, there is a sum and difference for the sine, and there's a sum and differences for the tangent. Alrighty? But these are just for the sum and differences for the cosine function. Alrighty? Alrighty. Alrighty. Now, right here is going to be basically a little demonstration by looking at the pictures of why the sum and difference formulas hold that you see in this table. I just need you to kind of look them over, write them down, but I'm not going to go over this here. They take a while, and you can look at them to see which ones and why they are true. But I will not hold you responsible for this. So I would just tell you right now to pause it and write these circles down and just see if you could figure it out. It's beyond the scope of this course to actually prove these formulas. Our scope is just to use the formulas. That's all. Alrighty? So the sum and difference formulas for the cosines. Alrighty. So let's continue. And we're going to use the sum and difference formulas to find the exact values. So we're going to find the exact value of the cosine of 7 pi over 12. Now, right now you have just seen why we have these formulas. Right now we have special angles. They are pi over 4, they are pi over 3, they're pi over 2, they're pi over 6, angles such as that. Now, do you remember why we called those special angles? Well, they're called special angles because when you evaluate a trig function at them, you don't need to pull out the calculator. Those are the ones that you have memorized by your chart. So, for example, the sine of pi over 3, I don't need to pull out my calculator to evaluate sine of pi over 3. It's the square root of 3 over 2. Or cosine of pi over 4, that's square root of 2 over 2. Those I have memorized. So those are my special angles. And so what this formula is going to do for us is to give us more special angles. Because 7 pi over 12 is not a special angle, as we all know. But if you add 2 special angles or subtract 2 special angles, you could come up with 7 pi over 12. 7 pi over 12 is the same thing as 3 pi over 12 plus 4 pi over 12. 3 pi over 12 is pi over 4. And 4 pi over 12 is pi over 3. And pi over 4 and pi over 3 are both special angles. Since they are both special angles, I can use this sum formula for cosine to evaluate it, and what results is a special angle because I never had to use my calculator. So remember that the cosine of alpha plus beta is the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. So I call it the first and second. So cosine of pi over 4 plus cosine of pi over 3. Cosine of pi over 4 plus pi over 3 is going to be the cosine of first, pi over 4, times the cosine of the second, pi over 3, minus the sine of the first, pi over 4, sine of the second, pi over 3. So it's just immediate use of the formula. And if you look at those values, those are all special angles, so it can be found with our memorization. So cosine of pi over 4 is the square root of 2 over 2. Cosine of pi over 3 is 1/2 minus. Sine of pi over 4 is the square root of 2 over 2. And the sine of pi over 3 is the square root of 3 over 2. And if you just plug and chug on those numbers, Square root of 2 over 4 is the first, and then square root of 6 over 4 is the second. So doing the math, it's the square root of 2 minus the square root of 6 over 4. Now, a couple things here. Square root of 2 minus the square root of 6 cannot be simplified. I know it's tempting to make it negative square root of 4, square root of negative 4, or negative square root of 4. But you can't combine square root of 2 minus the square root of 6. So that cannot be simplified any further. Okay? Now what you could do is use your calculator to evaluate square root of 2 minus the square root of 6 over 4. But that kind of, it's not a good idea, because you're basically, if you want the decimal form in the first place, if you wanted that in the first place, then you could just evaluate the cosine of 7 pi over 12 to begin with and forget the formulas here. So the whole purpose of doing all this work here is to get an exact answer. And square root of 2 minus the square root of 6 over 4, even though it's ugly, it's exact. So in other words, I can get what it equals to without a calculator. And that's the point. So cosine of 7 pi over 12 can be broken up. The hardest part about these problems here is figuring out the sum, or what difference is the angles that you're trying to find. So if you can add or subtract any two special angles, you get another special angle, in other words. All right. Okay, let's look at the next example. Using the difference formula for the exact value of a cosine of 15 degrees. So it's the same idea, except 15 degrees is the difference of two special angles. Can you think of two special angles that you can combine them that will give you 15 degrees? There could be more than one answer to that. I'm thinking of 45 degrees minus 30 degrees is what I'm thinking. And that's what he's thinking too. So the cosine of 45 degrees minus 30 degrees, that's 15. And then using your difference formula, which is at the bottom of this screen, cosine of alpha minus beta is going to be the cosine of 45, cosine of 30, plus the sine of 45, the sine of 30. And those are all special angles. They can all be evaluated without a calculator. And so the cosine of 45 degrees is root 2 over 2. Cosine of 30 degrees is root 3 over 2. Plus sine of 45 degrees is square root of 2 over 2. And the sine of 30 degrees is 1/2. And that turns out to be the square root of 6 plus the square root of 2 over 4. Now you're going to find that there is a lot of these answers that are not, that's like 15 degrees, that's got that square root of 6 and the square root of 2 in some order, some fashion involved. They could be minus, they could be plus, but in some fashion they may have those numbers involved in the answer. And so it's particularly dealing with angles that have 30 and 60 and 45 in them. All right? So keep that in mind. All right? That ends this discussion. If you have any questions, you let me know, and you have a good day.